Alright, this is a video to help you understand how to write electron configurations and to begin to understand the periodic table in even greater detail. So the first thing I want us to go ahead and do is take our blank periodic table and let's go ahead and do some marking on it. And first of all, this element right here, this is helium. And helium, for this purpose only, is actually going to move over here. So on our periodic table, we're going to go ahead and make a little box and put helium over here temporarily while we do this activity and while we learn about electron configurations. First thing then, you're going to go ahead and mark this area of your periodic table S block. Okay, I'll tell you what that means shortly. This right here is known as D block. Okay. And then this area right here, not counting helium of course, is called P block. And the parts down here at the bottom, where the lanthanides and the actinides are, where lanthanum and actinum are here, this part is called F block. And you won't really have to worry too much about F block, but this area right here is F block. All right, that's going to help you. Now keep in mind these 1, 2, 3, the periods, a total of 7. Those periods represent rings around the atom. So I don't know if you remember that our atom looks kind of like this, and the center of it represents the nucleus. So here's our nucleus. And around it are the various rings. Now these rings are also known as energy levels. I'm going to put energy levels here. And the energy levels are represented by what are called N equals 1, N equals 2, N equals 3, N equals 4, and these are a maximum of 7 energy levels. A maximum of 7. So guess what they correspond to? They correspond to the periodic table and what we know as the rows. So each row represents a ring on the periodic table. So back to the rows. So the rows represent a ring. And what we're going to see is each atom is getting one more electron than the next atom. One more electron than the next atom. And those electrons are going to start by being placed closest to the nucleus, and then as we go out, they're going to be added to the various energy levels as the atoms grow. So take the very first atom, hydrogen. The very first atom, hydrogen, has only one electron, and that one electron goes in the first ring. The second atom, helium, has 2, so it has 1 and 2. The third atom, lithium, because this first ring is filled up, it only holds 2 electrons. The third atom, lithium, holds 3, and that one goes into the third ring, as so. And so on and so forth. Now, the really easy way to remember it and to look at it is to look at the periodic table and to see how the periodic table shows you exactly where the electrons are going to fall. So let me go back to the picture that I had earlier with the blocks. So the first ring, the first energy level, represented by 1, and S block represents a sublevel called the 1s. So this first electron goes in the first ring around the nucleus, and it's called S. So the configuration for hydrogen right here is 1s1. Okay. The configuration for helium, which is right next door here, is 1s2. The little 2 up above means 2 electrons in the 1s. So that means that helium, first ring, is full with 2 electrons. Now, the periodic table, you read it as a book. So as you're reading it, you go across and you read it as a book. As you're reading it, from left to right, like this. And if you read it as a book, you'll never go wrong when it comes to filling up the electrons. So let's say we're doing an element way over here. element number 15. By the way, what element is number 15? Check your periodic table. Element number 15, actually let's do number 7, nitrogen, right here. Let's do number 7. So nitrogen number 7. So nitrogen number 7, which has 1, 2, 3, 4, 5, 6, 7, which is actually right here. That's nitrogen. So nitrogen's first electrons are going to go, starting from the top left, reading like a book from left to right, 1s1, 1s2. That's the first ring now. The first ring is full. Second ring has an S. This is called 2s. Second ring, S sublevel, 1. This element, 2s2. Continuing over here, now we're in P block. Remember how we wrote a P there? Second row, P block. So this is called 2P. 2P1, 2P2. Look at how big the P block is. The P block holds a maximum of 6 electrons. So this one right here, I'm guessing you're thinking about what it's going to be. It's going to be 2P. This one was 2P2. This one right here is 2P3. And then we stop. Why? Because we're doing this element right here. That's nitrogen. So nitrogen's electron configuration, if I was going to write it all out, is going to be 1s2. So when you write it out, you summarize the whole thing by summing up how many are in S? 2s2 and 2p3. So just to recap, where did I get all these numbers? So remember, 1 means the first row and also the first ring around the nucleus. 2 means the second row and the second ring around the nucleus. So this right here, 1s2, 2s2, 2p3, represents the electron configuration for nitrogen, which has a total of 7 electrons. And if you count these little powers, which represent the electrons, 2 plus 2 is 4, plus 3 is 7. That is the configuration for nitrogen. More later.